Okay, guys, you had to be, you're responsible for tonight, and I'm going to start uploading some more videos. I'm going to work on some videos this evening. But page 8, the light blue quotable, which was dealing with pretty much using coordinate geometry to prove parallel, or prove quadrilaterals is a parallelogram, or just prove any type of quadrilateral. So the first tab, you need to fill in the following points, the vertices. I think one class got this. So A was 3, 3, B was 8, 2, C 6, -1, and D 1, 0. So I need you to get the graph, the points on the graph, connect the points, label the points A, B, C, D, and then we're going to go into method 1, excuse me, which is proving that opposite sides are parallel to show that the slopes are the same or equal. So here, the next tab I have here at the bottom, prove the opposite sides are parallel to show the same slope. So we can use our slope formula, which I believe they give you on the front tab, which is the y2 minus y1 over x2 minus x1, or you can count your rise over run. I'm going to do both. Okay, so if I'm doing the points from A to D, we're just basically doing 0 minus a negative minus 3 over 1 minus 3. And that comes out to -3 and a -2, which can be simplified as just 3 over 2. Okay. Or I can count the rise over run. So if I look at BC, I can just put my pencil on C, count my rise. My rise is up 3 and then to the right 2. So BC is 3 over 2 as well. So if I notice that AD and BC have the same slope, then and their opposite sides, I'm proving that they are parallel because they have the same slope. And we're going to continue using the rise over run or the slope formula to compare the slopes A, B, and CD. So here, if I'm using the formula, this would be 3 minus 2, 3 minus 8. This comes out to be a -1/5 or positive 1 over -5, which is the same thing, 1/5. And if I do the same thing, if I count my rise over run from C to D, if I'm starting at C, I'm going up 1, but then to the left 5, or I'm starting at D, I'm going down 1 to the left 5. This also is a -1/5. So again, opposite sides are parallel. So I'm showing that AB is parallel to CD because they have the same slope. So I have proved that our quadrilateral, or ABCD, is a parallelogram because, this is my abbreviation, B/C, AD is parallel to BC, and because we have that both pair, AB is parallel to CD. So go ahead and add that to your little tab. Hopefully you have room, or you can do it on this page to the right, because we got another quadrilateral that we're going to graph. All right, so that was method 1. Then our next method is looking at the sides, see if they are congruent by showing lengths have the same distance. We're going to use our distance formula on this tab. So I kind of already had started AB. We're going to subtract the x coordinates, then square them, and subtract the y coordinates, square them, and then add them together, and then take the square root. So I have AB up here already. Now, if you wanted to, and I can just kind of, if you want to work a little bit smart and not overwork, we've already looked at the slopes. And so if I'm, like, for example, doing CD, I know the slope of CD was a -1/5. Okay. I just want you to notice something. I'm going to do the distance formula, and hopefully remember that the distance formula was derived from Pythagorean theorem and creating the right triangles with the sides. So doing distance formula with CD, I'm going to pretty much just do 6 minus 1 parentheses squared plus a -1 minus 0 parentheses squared. Well, this gets simplified. Well, 6 minus 1 is 5 parentheses squared. And with -1 minus 0, so -1 parentheses squared. And anytime we square a negative, it becomes a positive. So again, we basically have 25 plus 6, which is the square root of 26. Now the reason why I showed you the slope 1/5, because if you look, we have a 1 as a numerator. Whatever our rise is, that's what our change in y is going to be. And whatever our run is, so here we had the denominator was 5, that's exactly what our change in x is going to be. So if you want to use the slopes to find your distance formula, make sure you can do that, but just make sure you're not using the reduced slope. I know we simplify whenever we can reduce the ratio, just start with your original ratio. So check AB, the slope of AB was 3 over 2. So we should get that when we do the distance formula, when we simplify it, using our order of operations, completing the parentheses first. So, but if we're just going to plug it in, x2 minus x1, we're going to have 3 minus 1, and change in y, so it's going to be 3 minus 0. And then basically, remember we saw what our slope was, 3 over 2. So we're going to have 2, parentheses squared, 3 minus 2, 3 minus 1 is that 2. And then we got 3 again. And then we're just going to square that. 2 squared is 4, 3 squared is 9, 9 plus 4 is the square root of 13. And then we're going to do the same thing for BC. I'll just plug it in, but hopefully you see it's going to get simplified as the same thing as pretty much we're going to have 2 parentheses squared plus 3 parentheses squared, and it's going to come out to be square root of 13, not B. That looks like a B, square root of 13. Alright, so let's just put these measurements on here. So our AB was the square root of 26, and DC was the square root of 26. So now we're just showing and we're proving opposite sides are congruent. And then if I look also, AD was square root of 13, square root of 13, again, opposite sides are congruent. So I have proven that the parallelogram, or ABCD, is a parallelogram because we have AB, which is opposite CD, equal to each other. They have the same length or same distance. And we have AD equal to BC. And those are opposite each other, opposite sides, and they have the same length, the same distance. So you can use the distance formula to check the lengths. Now, the next thing we can do is we can prove using the diagonals. Now, the diagonals in a quadrilateral, especially of a parallelogram, have a special property. I'm going to start with a diagonal AC. The diagonal AC and my diagonal DB are intersecting each other. So, and they are bisecting each other. So AC gets bisected and DB gets bisected. So they're not congruent in a parallelogram. Ask yourself, what shape are the diagonals congruent? If you know this answer, you're probably pretty set for your test, or you did well on your test last week. You should know that that's a rectangle and that's also a square, or the diagonals are congruent. All right, so if I can prove that the midpoint is the same for both diagonals, then I'm proving it's being bisected, and then I'm proving that it's a parallelogram. So we want to check that they have the same midpoint. So I'm going to check the midpoint of AC. And so when we do the midpoint, add our x's together, take the average of the x's, average of the y. So our x's are 3 plus 6. I'm going to take half of that, and 3 plus a negative 1. This actually comes out to be 9 over 2, and that is a negative 1. Or we can simplify that as 4.5 and a negative 1. Either way I would accept, okay? So then we're going to check the midpoint of the diagonal BD. So I got to add those x coordinates together. So that's 8 and 1, and we have 2 and 0. And so that gets simplified again as 9 over 2. 2 over 2 is 1. I put negative 1, and that should have been positive 1. Apologize for that. Which again comes out to be 4.5 and 1. Alright, so what I've proven is that they have the same midpoint. And if they have the same midpoint, then they are bisecting each other. So if the diagonals bisect each other, then it's a parallelogram. So I can state that ABCD is a parallelogram because AC bisects BD and BD bisects AC. They bisect each other. And that only happens with the parallelogram. Well, it happens in some other shapes, but those shapes are also parallelograms as well. So make sure you have that. And then the last thing we're going to look at, our last little tab, is proving that the other way you can prove that you have a parallelogram is if you look at only one pair of opposite sides and that same pair of opposite sides showing that they're congruent as well. Okay, so what I'm trying to check is we're going to check that. Oh, I need my little. We have A, B, C, D. I want to look at the slope of AB. I want to see if AB, which is opposite CD, have the same slope. I'm going to put the arrow, but I want to prove that calculating their slopes. Well, I can count the rise over run, or I can use the slope formula. But we did this already, and we know that this is a negative 1/5, and this is also a negative 1/5. They have the same slope. So I'm proving that they're parallel. Then I want to look at the distance of AB. We did this already. And we also remember, I talked about how you can just use your numbers in your ratio to represent your slope. So basically we had square root of 26 and the square root of 26. Wait, 1 squared plus 5 squares is 26. So I'm proving that the opposite sides are also congruent. So notice that it has an arrow and a tick mark. Arrow and tick mark. So if I'm showing that they are opposite sides, one pair of opposite sides are parallel and congruent, then I'm proving it's a parallelogram. Okay? So you can do that as long as you're looking at the same pair of opposite sides. So ABCD is a parallelogram. Because AD, not AD, but AB, excuse me, is parallel to CD, and AB is congruent to CD. So once I'm showing that they're parallel and congruent, then I have proved it's a parallelogram. So understand these methods to show different characteristics to different quadrilaterals are important because there's going to be times where you have to show that consecutive sides are perpendicular. So the slopes have to be opposite reciprocals to show that maybe the diagonals are perpendicular. And that lets me know that we're looking at a square or a rhombus. So understanding that doesn't happen with a rectangle or a parallelogram. So knowing the different parts to use to prove different characteristics to the quadrilateral is very important. So please get this completed. What I need to check, basically, you had a graph, or I gave you some order pair for page 8, I believe it was. On page 9. And let me make sure you have those. So on page 9, you had the order pair. A was a negative 1, 2. B was 1, 5. C was 4, 3. And D was 2, 0. So with your graph paper, I want you to create a coordinate plane, graph these points, and I want you to prove to me what the quadrilateral is. What quadrilateral is created when you connect these vertices together. All right, and then I'm going to give you another one. So just hold on just a second. Let me put it up here. Well, I thought I was going to get to insert a graph, but I can't do it. So I'll be working on this. So let me just at least give you the points for the second one. I need you to graph. So this is example 1, example 2. What I want you to do is the following point. So G is going to be negative 4, 4. H will be negative 1, negative 2. I will be negative 4, negative 5. And J will be negative 7, negative 2. Okay, so graph those 4 points, connect them, prove the type of quadrilateral that you think it is. So don't just go based on what it looks like. You need to prove it either looking at the slopes, looking at the lengths using the distance formula, or looking at your diagonals. Okay, so looking at the midpoint, proving a bisector. So do one of those methods that you have on your foldable to prove it's a quadrilateral. So these are the two I'm going to check for. All right, thanks guys for taking care of this. I'm going to start working on the next videos.